Hi, and welcome to Fraction Multiplication Part 2. We're moving on from Part 1, where we took a look at whole number multiplication and whole number by fraction multiplication. We're now going to take a look at multiplying one fraction by another. And in this case, we have 1/3 times 3/4. And let's pretend that the context here is a chocolate bar. So the question might be, um, there's 3/4 of a chocolate bar just sitting there, and you come along and eat 1/3 of it. How much of the chocolate bar did you eat? Now that last part of that question, how much of the chocolate bar, is how much of the whole, right? So let's take a look at that whole because it's very important for students to have an understanding of what the whole is. Here's the whole chocolate bar, okay? But that's not what we have. What we have are 3/4 of the chocolate bar. This is what we're dealing with, 3/4. If I eat, or if somebody eats 1/3 of this, then how much is that? Okay, well, let's represent the 3/4 in a different way with 3 1/4 blocks. And I'm going to just move these out of the way to isolate them for a bit. And we're going to focus right now on what's going on here. This is not the whole chocolate bar, it's 3/4. Now, if I eat 1/3 of that, that means I'm eating one of 3 equal pieces of that. And what is one of 3 equal pieces of that bar? That. Because there are, put that down, erase that, there's 1, put that down, erase that, there's 1, 2, 3 of them. So this is my answer. I'm eating 1/4 of the chocolate bar. This right here is 1/3 of this, 3/4, but the answer is how much of the whole chocolate bar. So when I get my answer, I need to be comparing this to the whole, and of course it's 1/4. So the answer to this question is 1/4. Now, I did not have to split up any of these parts, which sort of makes this question a little bit easier for me to conceptualize. I don't need to break anything up. When students see this, they may look at the numbers above and they may say, well, wait a minute, I have a 1 here in this numerator, I have a 4 here in this numerator, but I've got a 1/4. I've got a numerator of 1 and a denominator of 4. And they may wonder, is there something to this? And that's a really good question for you to investigate, particularly considering that you have a 3 in this denominator and the same number 3 in the numerator of the other factor. So what this is telling us right here is we need to take one of 3 equal pieces. This numerator is telling us that we have 3 equal pieces. And so if we're taking one of 3 equal pieces, we're taking one of these quarters, and there's our answer, 1/4. It's good for students to understand this and to know what's actually happening in this multiplication question, instead of teaching them, as I was taught many, many years ago, that when you have a question that looks like this, that is structured this way, that the 2 3's magically cancel each other out, and that the answer is going to be 1/4. There's nothing magical about this. We need to teach students that when a question is structured this way, it's actually quite logical to lay out, in this case, 3/4, and to see that the first fraction, the first factor, is asking us to take one of 3 equal parts, which we have right there. And so the answer to this question would be 1/4. Now the algorithm will work, and we've not introduced the algorithm yet, but we don't actually need it here, and some students may discover it on their own, but it's really not required. Now, not all fraction multiplication questions are laid out that way where you can use logic, and sometimes some of them get a little more challenging because you actually have to subdivide unit parts. And so we're going to take a look at questions of that nature right now. So let me clear this, and we'll go with blue this time. And let's consider this question. We'll say 3/5 times 3/4. Now, what I'm not going to do here when I'm teaching this to my students is tell them to multiply the numerators and multiply the denominators, and there's your answer. Some students may have an idea that that's what is meant to happen based on what they've witnessed in prior activities and lessons. But we're still not going to introduce that yet. We're going to let them come to it. So a strategy here is to, in order to get them to build that algorithm, we're going to get them to consider a whole. So let's say this is the whole. And first of all, let's contextualize this problem a little bit. Let's say that we have a garden, and there's my whole garden. At one point, I planted 3/4 of my garden with carrots. And on a particular day, I want to harvest 3/5 of the carrots. So, what might that look like? Okay, well, I planted my garden, so I'm going to divide my garden into 3/4. So originally, this was my garden, and I'm just going to mark the 3/4 where I currently have carrots. There they are. Now, on a particular day, I want to harvest 3/5 of my carrots. So I am going to first switch colors, and I'm going to divide this 3/4 that we see into fifths. And I hope I can do this accurately. That's 1/5, 2/5, 3/5, and 4/5. I've only divided the carroted section of the garden. Okay, and I am going to select 3 of those fifths. So I harvested this fifth, I'm harvesting this fifth, and I'm harvesting this fifth. So the area of my garden that is marked in blue and red is the section that I have harvested. And so I need to take a look at that section and compare it back to the whole garden and find out how much of that whole garden am I harvesting. So I'm going to take these red lines that I drew, and I'm going to continue them to allow me to break down the whole garden into equal sized portions. Okay? And if I take a look at the parts, I have 20 parts. There are 5 rows of 4, so I have 20. And how many of those parts am I harvesting today for carrots? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of these parts am I harvesting. Okay, and there's my answer. Now I know that you can see 3 times 3 equals 9, and 5 times 4 rather equals 20, and a lot of students will see that too. But in order to connect, we need to connect that procedure to the image that is in front of them. So let's consider the part of the garden that is being harvested is a 3 by 3 square, right? And this is where we're getting our numerator from. That the two numerators and the factors are defining the area of the square that is being harvested now. That's the part that we're dealing with, right? The denominator is 20. It's a representation of the whole. The whole square, change colors here, the whole square is divided into 20 equal portions, and it's the denominators that multiply together to give that. Okay, remember that when we're dealing with fractions, we have it is a single value comprised of 2 parts. The denominator is the representation of the whole, in this case the whole garden being broken down into 20 parts. The numerator is the part of the whole that has been selected, or the part that we're talking about. In this context is the amount of the garden that is being harvested today. So the numerator is, and the same is true with the fractions and the factors. So the numerator is quite literally, we see in the diagram, the numerator of the product is quite literally a construction of the two numerators and the factors, and the same holds true for the denominator of the product. It is created by the denominators of the factors, and we can see that right in our image. By this time, it's unavoidable that students will see relationships between the numbers and will derive the standard algorithm for multiplying fractions. But it's very, very important that they see that these values in the calculation exactly and necessarily derive from the values in the model. They need to see that connection, that link between the model and the procedure. And so using a representation such as this one provides them that link. When students are taught only the procedure without seeing what it looks like or what it means, it is meaningless to them, and they don't have the depths of understanding that they need in order to use it flexibly and fluently in various contexts. So as much as possible, it is very important to provide those representations that create that link between what's happening in the procedure and what is happening in what is actually happening in the operation, what the concepts are. So that is the link between the area model and the procedure, and that's going to wrap it up for part 2. In part 3, we'll take a look at another version of the area model that will extend our understanding of fraction operations into fractions greater than 1.